determine the convergence of the series minus 6 raised to power n over 5 raised to power n running from 1 to infinity.
Okay.
You've written that?
Yes, I have, sir.
Okay. Now, to determine the convergence of this, the first thing you will do is you first determine if it is a GP or not. Do you understand that now?
Okay.
So you first determine if it's geometric series.
Oh, yes. Okay.
So how do you determine if it's a geometric series? You do that by listing out some terms of the series. So minus 6 raised to the power of n over 5 raised to the power of n running from 1 to infinity. So let's list out about 3 or 4 terms.
Okay.
So if n is 1,
yeah,
I will have minus 6 over 5 plus, if n is 2,
we'll have 36.
no,
Sorry.
no, don't do it that way.
No, oh, sorry.
Yeah,
Oh,
don't do it that way.
okay.
Of course, that's what it will result to, but let's first of all be explicit.
Okay.
Let's be explicit. Now, you can see that this series, because each of the numerator and denominator, or we want to say that both raised to power of n, I can make it compact by saying minus 6 over 5 raised to power of n. Now,
Yeah.
that's possible.
Yes.
So on that premise, my second term now, I'm going to write it as, okay, don't worry. Let me just be explicit so that you get better understanding of it. So if n is 2, we have minus 6 raised to power 2 over 5 raised to power 2 plus, when n is 3, minus 6 raised to power 3 over 5 raised to power 3 plus, when n is 4, minus 6 raised to power 4 over 5 raised to power 4 plus, and so on. Now, looking at it closely, I can say this is minus 6 over 5 raised to power 1, if you want to say that, minus 6 over 5 raised to power 2. By law of indices, this is possible. Do you agree with that?
Yes.
Okay. Minus 6 over 5 raised to power of 3. Then minus 6 over 5 raised to power of 4, and so on. So what do we do next? I will now check if it is a GP. If it is a GP, there will be a common ratio. Am I communicating?
Yes.
So you may want to call this one first term, second term, third term, and fourth term. So common ratio R is succeeding term over preceding term. That is T4 divided by T3. So T4, which is minus 6 over 5 raised to power of 4, divided by T3, which is minus 6 over 5 raised to power of what? 3.
3.
Is that clear?
Yes, sir.
So we can say that this is what? It's
Yeah.
the same thing.
Yeah.
So by law
I
of
think
indices,
minus 6 over 5.
very good.
Uh-huh.
Minus
Yeah.
6 over 5. Using law of indices now.
Oh, 4 minus 3. Yeah.
Exactly.
Uh-huh.
So that will be 4 minus 3, which is 1. And that will give
Yeah.
you minus 6 over 5. So I've done T4 over T3. Now I
Okay.
cannot do 1 and conclude that it's a GP.
Okay.
So you have to do the remaining. So I have to do now T3 over T2, which is minus 6 over 5 raised to power 3 divided by minus 6 over 5 raised to power of 2. And that will be minus 6 over 5 raised to power 3 minus 2. And that is 1. So you have minus 6 over 5. And that is what we have for T4 over T3.
Yeah.
You've written the question, right? I want to scroll up.
Yeah. So I'm just writing the solution.
Okay, let me
But,
scroll up a bit.
okay.
So let's now do T2 over T1. So that will be minus 6 over 5 squared divided by minus 6 over 5, which is raised to power 1 there. So that will be minus 6 over 5. So we can conclude that the series,
It's convergent.
no, is
Okay.
geometric.
It's geometric. Yeah. Okay.
The
Okay.
series minus 6 raised to power n over 5 raised to power n run from 1 to infinity is geometric. But that was not what the question demanded from us. The
Determine the
question
convergence.
demanded from us that we should
Yes.
determine if it is convergence. Now, we have to do this ourselves to answer that question. So reason for checking out if it is geometric, because we know
Yeah.
if it is geometric, all we need to know to decide if it is going to be convergent or not is the common ratio.
Yeah.
Is that clear?
Yes, sir.
Okay. So the common ratio is minus 6 over 5. R equals minus 6 over 5. Now, sorry, let me allow you to write this so that when I scroll up,
Okay. Okay. So I'm just finishing.
okay.
Okay. I'm there, sir.
Okay. So we will now take absolute value of the common ratio. So absolute value of R will be equals to
Hmm.
absolute value of minus 6 over
All right.
5. And that is 6 over 5, which is greater than 1. Do you agree with that?
Ooh,
Because 6
greater
over
than.
5, that should be around 1.2.
Okay.
I'm
Yeah.
right.
So, yeah. Yes, sir. So it's
So
divergent.
it's,
Yeah.
it's very good. It's greater than 1. And we have said that if the geometric series has a ratio, common ratio greater than 1 or
Yeah.
equal to 1,
Mhm.
according to our statement earlier,
Yeah.
then it is what?
It is divergent.
Convergent. I mean, it is divergent.
Yes, sir.
So it's greater than 1. Hence, the series summation minus 6 raised to power n over 5 raised to power n running from 1 to infinity is divergent. So write that.
Okay. On this one.
Okay.
Nice.
Yeah. Let's now look at what we call telescoping series. Telescoping series. So when do you say a series is a telescoping series? Have you heard about that before?
No, sir. But I'm guessing telescoping series.
Maybe you want to
Maybe,
use the word telescope, have you?
yeah. Trying to.
Okay, right? A series is called telescoping if the terms of the sequence or of the series if the term of the sequence or the series can be reduced, or you say it cancels out if the terms of the sequence of partial sums reduces to one or two terms. As a result of cancellation. Of terms. You get that now?
Yeah.
So when you have a telescoping series and you try to expand it, write it explicitly. That's the meaning. You just discover that from afar, you can see terms that will cancel out. So when that happens, then you say that that series is a telescoping series. So the cancellation will cause everything or the terms of the sequence or series to reduce to 2 or 1. It will be reduced to something that can easily be determined to work on, so to say. So let's see this example. Have you written this?
Yes, I have.
Okay. So this one says, show that the series summation 1 over n minus 1 over n plus 2, n running from 1 to infinity is telescoping.
Telescopic.
And determine its convergence. Determine its convergence. Is that clear?
Yes, sir.
So how do we go about that?
We
Please
can
write
find
the
this.
question.
Okay.
Write the question quickly.
Okay. I'm there, sir.
Okay. So what we are going to do is to get the partial sum, Sn, by taking values for n. That is, I will start by saying when n is 1, when n is 2, and so on. So we have summation 1 over n minus 1 over n plus 2, n running from 1 to infinity. So the partial sum, Sn, will be when n is 1, I will have 1 over 1 minus 1 over 3. Do you agree with that?
Yes. Yes.
Plus, when
Plus
n is 2,
1 over
1
2
over 2 minus 1
minus
over 4. Do you
okay.
agree with that?
Yes, sir.
Plus, when n is 3, minus 1 over, that is 1 over 3 minus 1 over 5. Am I communicating?
Yes, sir.
Plus, when n is what now? 4.
When n is 4, yes.
So 1 over 4 minus
1 over 6.
1 over 6. And that trend will continue to when n is n minus 1. That's second to the last term. Am I communicating?
Yes, sir.
When n is n minus 1. So I will substitute n minus 1 for 1 over n. So that will give me n minus 1 minus, substitute n minus 1 for n in 1 over n plus 2. That will give me
N plus 1.
n plus 1
Yes, sir.
plus the last term when n equals what? N,
Okay.
the
When
last
n.
term.
Okay.
So that will be 1 over n minus 1 over n plus 2. That's the last term. Now look at it. Let me change the color to blue so that we'll be able to see terms that will cancel out. Look at, I have here minus 1 over 3. I have here plus 1 over 3. Have you seen that?
Yeah. Yes, sir.
I have here minus 1 over 4. I have
Yeah.
here plus 1 over 4.
Mm.
Do you see the logic there?
Yes, sir.
Okay. So that means if I continue that trend, I'm going to have another term that will cancel out 1 over 5. Is that clear?
Yeah. Yes, sir.
If I
Yeah.
continue with that trend, I'm
Okay.
going to have a term that will cancel out 1 over 5. So
Yeah.
this term will go away. This one goes away. This one goes away. This one goes away. And this one will be out by another term. This one will also be out by another term. So the
Mm.
only term I'm going to have remaining, if you want to see, that means you have to go beyond where we stop. Oh,
Yes,
no,
sir.
we stop at when n is 6.
Yeah.
Okay, maybe we should, let me show it here. When n is 7, you have 1
Okay.
over 7 minus 1 over,
9.
no, do we stop at n is 6?
N is 1, 2, 3,
No,
4,
4.
5.
When n is 5, so we have 1 over 5, then 5 plus 2, that's 7.
Yeah.
So you can see that this 1 over 5 will take care of this.
Cancel. Yes.
Do you see that now?
Yes, sir.
If you go to
And
n equals to 6,
6. Yeah.
so you have 1 over 6 minus 1 over 8. So you can see that this will take care of this.
Yeah.
So you will now be left with 1 over 1, which is 1, plus 1 over 2 from the second term here. Am I communicating?
Yes, sir. I'm with you.
Then this term, you will see that the term that we cancel out after 1 over 2 has been the first term of that is the 1 over n of the term of the series. So this term will also be cancelled out by another term. This 1 over n will also be cancelled out by another term. So you now be left with this and this. So you now have plus minus 1 over n plus 1 plus minus 1 over n plus 2. Did you get that? You will see
Sorry. Not really. No.
that, okay, look at each of these brackets.
Yes.
In the first bracket, it is the second entity in that bracket that cancel out the first entity in the third bracket.
Yeah. Yes.
The second entity in the second bracket cancel out the
Absolutely.
first entity in the fourth bracket.
Okay.
And
Okay.
that trend
Yes.
now continues to cancel out.
Yes, sir.
Do you get that now?
Yeah.
With the
Yeah.
first entity canceling out like that.
Yeah.
So if that trend continues, so this term will also go away. This term will also go away. These first two, in these last two brackets, this first
Yeah.
entity and this first entity will go away. So you will
Yeah.
now be left here. You left with this and this. So do you understand that now? So this will now reduce to 1 plus 1 over 2 minus 1 over n plus 1 minus 1 over n plus 2. Am I communicating?
Yes, sir.
Which I can, let me scroll up. I can add 1 and 2 together. If I add 1 and 1 over 2 together, that will give me 3 over 2. Is that clear?
Yes, sir.
Okay.
Right.
Minus, now I can take LCM of 1 over n plus 1 and n plus 2. I can take LCM of that. Do you agree with that?
Yes. That'll be,
But let me
yeah.
first of all factor out minus. If I factor out minus there, you have 1 over n plus 1 plus 1 over n plus 2. Is that agreeable?
Yes, it is.
Okay. So if you do that, what do we get now? 3 over 2
We get
minus,
brackets. Yeah,
okay,
n plus 2,
okay,
n+1
n plus 1,
over,
product of the two.
yes.
So that will now be 3 over 2 minus, that's 3 plus 2n over n plus 1, n plus 2. Is that it?
Okay. That's 2n, 3 plus 2n. Yes, that's right.
Okay.
Yes, sir.
So that means you can see that we've been able to reduce it to two entities now.
Yeah.
So that's what we mean by telescoping series. So because we've been able to reduce it to two entities, then we have shown that is a telescoping series. You can see that we have terms that cancels out.
Yeah.
Okay. Please write that quickly. We have less than 10 minutes.
Yes, sir. I'm with you, sir. I'm there.
Okay. Now let's now answer the second part of the question. What's the second part? He said we should determine its convergence. So we are going to determine the convergence of that by taking the limit of the partial sum. So limit of xn as n tends to infinity will now be limit as n tends to infinity of 3 over 2 minus 3 plus 2n
2n
over n plus 1, n plus 2.
plus 2.
Now, I can open up this denominator.
Okay.
If I open it up, I'm going to have it in quadratic. Do you agree with that?
Okay.
So
Yeah.
limit
And
as n tends to
yeah.
infinity of 3 over 2 minus 3 plus 2n over, so that will
N
be n
squared
squared
plus 3n
plus 3n plus
plus
2.
2.
Now, you now separate the limit by rule of limit. So to be limit of sum is sum of limit. So I will separate that. Sum to infinity, limit as n tends to infinity of 3 over 2 minus limit as n tends to infinity of 3 plus 2n over n squared plus 3n plus 2. Now, how do I evaluate the limit of this type? The rule says divide by the highest power in the denominator. So the highest power of variable in the denominator is n squared. So I will divide both numerator and denominator by n squared. So I'm going to have limit of 3 over 2 as n tends to infinity minus limit as n tends to infinity of 3 over n squared plus 2 over n over 1 plus 3 over n plus 2 over n squared. Remember, we did all these things when we started this course. Now,
Yes, we did.
I know you have forgotten.
No, 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 sir.
Okay.
Yeah.
Now, let's now evaluate. Limit of constant is constant. So there's no n in 3 over 2 that we want to substitute for. So it will be 3 over 2. Then substitute limit here, infinity for n here. So 3 over infinity squared is infinity. So
Yeah.
3 divided by infinity, 0. Understood?
Yes, sir.
So minus 0 plus 2 over infinity, 0. Over 1 plus 3 over infinity, 0. 2 over infinity squared, 0.
0.
So everything here becomes what?
0.
0.
0.
So you now have
3 over 3 over 2.
3 over 2. So the limit is finite. Am I communicating?
Yes, sir.
Since the limit of the partial sum is finite, then we'll now conclude that what? The series is convergent.
Yes,
And
sir.
it converges to what? 3 over 2. Hence, the series, what's the series?
The series is
Summation 1 over n minus 1 over n plus 2, n running from 1 to infinity, is
divergent.
convergent.
Convergent. Okay. It's finite. Yeah.
Yes,
Okay.
it's
Okay. So I was
convergent in
thinking.
this case. Why is it
Okay.
so? Because 1 is a telescoping series whose partial sum, do you get that now, is finite.
Okay.
Now, remember we considered, I gave you a definition that says the sequence AN, its series, for given the sequence AN, the series is denoted by this, is what? Is convergent if the partial sum is convergent.
Okay.
Understood?
Yes, sir.
So
Three,
hence the series this
one.
is convergent. You want to say it's divergent because it
3
converges to a
over.
value that is greater than 1? No, this is not
Yes.
ratio. It's not ratio. It's not
Yes,
common
sir.
ratio. The 3 over 2 is not common ratio. Do you understand that now?
Okay, sir.
The series we have obtained is not a geometric series.
Yeah. It's
It's a
not a geometry.
telescoping series.
Okay. Yes. Okay.
So don't mix them up.
Okay, sir.
So that's a convenient point for us to stop.
Yes.
Hope you are writing that.
Yes, I'm done, sir. I'm done.
Okay. So but it will be fine if I give you something to play around with.
Okay.
So take this one as assignment. The question says, the number 3.421 251 251 and so on is equal to 3.42125 with bar on 125 is periodic
Whoa.
with period 125. That means it's recursive at that point. That's the meaning. Do you understand that now?
So I don't think so.
Okay, don't worry, you will get it. Determine
Okay.
if it is geometric. Determine if it is geometric series. All right.
Okay.
Also decide if it is convergent. Yes. So that's it.
Okay. I wrote it.
All right.
All
Bye.
right, sir.
Yeah.
Yeah. Bye, sir. So, sir, next week or tomorrow? Next week, I mean.
Tomorrow, I will let
I
you
know.
know. When will you be available?
No, it's still like this same time. I'll be available 4 to
4 to
5
5.
p.m.
All right.
But
Yeah. I will send you a message that is feasible.
okay, sir. If not, no, it's okay. Yeah. All right. No problem. If
All
I'm
right.
still on track, sir, for January, but
Okay.
that's fine.
Okay.
All right. Thank you,
Bye.
sir.